Hello. Today we're going to be working with exponents, and before we get into the meat of what we're going to look at, we're going to talk about some of the old exponent rules that we learned in past years. So the first example I have that tells us to simplify is x to the third times x to the fourth. And if you recall what that means, when we take x to the third, that's the same as x times x times x. And we're multiplying that by x to the fourth, which is x times x times x times x. So in grand total, we have 7 x's multiplying together. So that would be the same thing as x to the 7th. Or if you remember, when multiplying, we add exponents. Okay? In the second example, we have x to the 7th divided by x to the 12th, x to the 7th divided by x to the 2nd. So in the numerator, we have 7 x's multiplying together. 6, 7. And in the denominator, we have just 2 x's multiplying together. And so if we go through here and we cancel with these on top and bottom, they divide out and we get 1. These divide out and we get 1. We have left 5 x's in the numerator. So the final result is x to the 5th over 1, or just x to the 5th. And so the rule we came up with was, when dividing, subtract exponents. Okay, and then finally we have x to the 4th to the 2nd. So this is telling us, because we're taking it to the 2nd, we're taking x to the 4th times x to the 4th. Or what that means is we're taking x times x times x times x multiplied by x times x times x times x. And so 2 times we're taking 4 x's and multiplying them together, and we're getting a final result of x to the 8th. If you count up 8 x's all multiplying together. And so the rule here was, for a power to a power, multiply exponents. And so you can see how the 4 times the 2 makes 8 in this bottom one. Let's look at one more before we move on. So in this slide, I have x squared to the 1/2. And so how would we deal with this? Well, this is what we literally just talked about. We have a power to a power. So we would take our two numbers, the 2 and the 1/2, and we would multiply. And we would get x to the 1st, or just x. So why is it that squares and something to the 1/2 cancel each other out? Well, what else cancels out something that's squared? And that would be if we took x squared and we square rooted it. So a conclusion we can come up with is an exponent of 1/2 is the same as a square root. Okay, well, does that extend to other things? Like if I take x cubed, what would cancel with that? What would I multiply by 3 to get x to the 1st? And that would be 1/3. So there's a result of x, and so it stands to reason that the cube root of x cubed would just be x. So this must mean that an exponent of 1/3 is the same as the cube root. And so on. So we can build upon this to start talking about how an nth root is the same as the exponent of 1 over n. Figuring out what we just figured out then, we can write this statement that for any number a and any positive integer n, if we take a to the 1 over n, it's the same as the nth root of a. So, as an example, a to the, let's say, 1/7 is the same as the 7th root of a. Or if I wanted to get more specific, let's say we did 64 to the 1/3. That's the same as the cube root of 64, which just ends up being 4. So let's go even a little further still. If I'm looking at something like, we'll say 27 to the 2/3. How do I simplify something like that? Well, we can split it up into two different things. I can look at this as 27 squared to the 1/3. I wrote it as a power to a power, and I know that I could take 2 times 1/3 to get 2/3. So we can convert that to be the cube root of 27 squared. And if we did the cube root of 27, we're just going to come up with 3. We haven't used the square yet, so it's still squared, which results in 9. So we have another rule we can write. And here it is. This time if we have our number a and our positive integers are m and n. So we write our fraction as a to the m over n. And we can convert it. The denominator n is still my nth root, so the nth root of, and then the numerator m is the exponent, the nth root of a to the m power. Again, we can talk about it using power to a power. If a to the m divided by n is the same as a to the m to the 1 over n, well, I know that 1 over n converts to the nth root of a to the m. And there's your explanation of why that works. And we'll call it a conclusion with there. So we are done.